Hi, this is Raquel Ludke, and I will be discussing my findings on the effects of caffeine on motor function. This study was conducted to see what levels of caffeine consumption motor function becomes impaired at. In order to begin this experiment, I needed to review other works and studies to see what base information I could start with, and to make sure that my previous information had been correct. I discovered that caffeine has many adverse reactions in the body. It can affect memory, anxiety, and of course motor functions. Of all of the studies that I looked at, one experiment seemed very telling of the reasons for motor function impairment because of an increase of caffeine intake. This experiment was performed on lab mice, and the people conducting this experiment were able to see that an increase in caffeine consumption correlated with skeletal muscles and the disturbance of caffeine ions, making those skeletal muscles not perform properly. So within this experiment, they were able to conclude that the increase of mobilized intracellular calcium ions compromised motor function, or at least the motor function of the skeletal muscles within these lab mice. So now that we are able to have the basic information on the caffeine effects, we can then continue with our experiment. In order to perform this experiment, we must have a null hypothesis. The null hypothesis in this situation is that there is no significant change in motor function from caffeine intake at any of the dosages. So for the 40, 80, and 120 milligrams of caffeine, there would be no difference between the motor function at each one of those as there is at the 0 milligrams of caffeine or at control. So the independent variable for this study would be the dosage of caffeine given to the participants. Again, 40, 80, and 120. The dependent variable would be the degree to which the participants are able to complete the motor function test. This motor function test is just a swirl in which they must follow and trace the line properly. Each deviation from the swirl would be a point removed. For this experiment, we had the motor function test, a stopwatch in order to monitor the intervals in between the caffeine chews, the caffeine chews, which were 40 milligrams each, and a document in order to record our data. So for this experiment, we created a basic motor test and had each one of the participants fill it out. So what we had was a 0 milligram section, 40 milligrams, 80 milligrams, and 120. So when the participants had been given no caffeine and had not had caffeine for the beginning of the day, we gave them the sheet and they filled out the 0 milligram section. We then gave them a 40 milligram caffeine chew and allowed 30 minutes for the effects to kick in. We then had them fill out the 40 milligram section of the motor test. We repeated this for the 80 and 120 milligram section. We then had the participants come back at the same time the next day and fill out these tests again with the control and then each one of the increase in caffeine consumptions. After the total 3 days, we were able to compile the data of each one of the 6 participants and compare it to each other. We made sure only to compare the data to each one of the participants on the given day, to make sure that there was no variance among each one of the days and the difference between how the participants filled out their motor sheets to begin with. We wanted to make sure that the effects of their memorization on the motor sheet also did not play a role in the effects of this study. To represent the data, I looked at the deviations of each participant's tracing of the motor function test and compared that to the control for that day, and then provided with the value of increased or decreased deviations from the path for each one of the caffeine levels. These data points are then compiled on the charts presented on the screen. The means were then found for each one of the data sections, as all of them were placed in the same pool, given that they were only being compared to that controls for the day. The means were then found for each one of the data sections, and given this information, we were able to conclude that the increase in deviations are statistically significant enough to disprove the null hypothesis for each one of the caffeine values. This study was able to conclude that an increase of caffeine consumption will lead to a decrease in motor function for each one of the caffeine levels provided. The use of 6 participants over 3 trials allowed the data to support the hypothesis that we presented and reject the null hypothesis. Through the use of t-statistic tests, we were able to conclude that our data was statistically significant enough for each one of the following caffeine levels: 40 milligrams, 80 milligrams, and 120 milligrams of caffeine consumption. Motor function was decreased from the control, which was 0 milligrams. These were represented by deviations from the motor function test, and each deviation was a decrease in motor function. The results could be varied due to the population, and the study could be repeated with a larger sample for more accurate findings. The study could have also included multiple forms of motor tests for the participants to perform to make sure it was accurate. The study was also complicated by each of the participants completing the sheet differently. This was combated by them only being compared to each sheet with no cross comparisons. Given the way the experiment was conducted and the sheets being checked by hand, a bias may have come into play, affecting the results and making them not as consistent as a program could have detected.